Thanks again. And I guess we can all agree that affirmative action is widely used around the world, but it's not without its problems and controversies. So, for example, the Indian government runs one of the largest affirmative action systems in the world, where they use centrally administered exam scores in order to allocate the government jobs to the candidates. But they also include reservations, so protections for individuals who belong to certain underrepresented castes as well as women. Unfortunately, the main rule they used to allocate these government positions suffered from very important deficiencies, including the fact that there were instances where individuals failed to obtain certain jobs particularly because they belong to certain underrepresented castes that are exactly the target group of these affirmative action policies. As you can expect, these issues resulted in a great deal of controversy, including hundreds of court cases in various levels of Indian judiciary. And at the end of the day, this rule was rescinded recently in 2020 after being in use for the last 25 years. The Brazilian university admissions suffered from similar issues where individuals may get a less preferred college because they belong to certain underrepresented racial minorities or they invoke their low-income privileges. And in that particular case, the students are allowed to whether declare or not these particular groups that they belong to. As a result, the final mechanism was not even incentive compatible. As these two examples and many others in the literature suggest, there is a tension between goals or the preferences of the institutions and the policies that they implement. So motivated by these issues, in this paper, I present a model where individuals are heterogeneous in two domains. The first domain is their possibly multidimensional or overlapping identities, such as gender, race, or income. And the second dimension is their scores, which you can think of as score obtained in a centrally administered exam or any kind of preference the institution have that is independent from the identity of the individuals. Unlike the previous literature that focuses on these choice rules and affirmative action mechanisms through characterizing them through certain axioms, I'll focus on the preferences behind these rules and formally define these preferences as preferences over sets of individuals that can freely depend on the distribution of scores and distribution of characteristics within each possible set. Using this model, I'll first characterize the choice rules that are rationalizable with a preference relation that's increasing in scores, which means that starting with a set of individuals, if we increase the scores of certain individuals in that set, the resulting set should be more preferred compared to the initial set. And as an application, I'll show that the rescinded rule in India not only suffers from these deficiencies like incentive compatibility and respecting the affirmative action target group, but it's not even rationalizable with these kinds of preferences. So it couldn't have been designed by a rational decision maker with well-defined preferences. Next, I'll switch the gears a little bit and I'll try to understand how different ways of evaluating diversity interact with certain properties of the choice rules. And in particular, I'll show that if diversity is evaluated using the marginal distributions, which, for example, you can look at the number of men, women, or minority and majority race individuals in your setting, then instead of particularly looking at the cross-sectional distribution, for example, let's say the number of majority women, then the choice rule induced by these preferences would create complementarities between individuals of opposite groups. And as a result, the choice rules and the affirmative action mechanisms induced by those kinds of preferences that does not take intersectionality into account will violate this crucial substitute condition, which is necessary for the existence of stable allocations and equilibrium in many settings. Finally, as the diversity domain and the score or match quality domain is not inherently connected, I'll characterize the rules that are rationalized by utility functions that treat these two domains in an additively separable way, which means that there is a term that only depends on the scores of chosen individuals. And there's another term that depends on the composition of identities within that set. And the total preference is obtained by summing those two terms. Perhaps surprisingly, this class of choice rules are fully characterized by three well-known properties: the substitutes condition, an adaptation of a responsiveness condition, and an acyclicity condition, which is the main condition that's used in choice theory to characterize additive separability. I'll then show that I'll then map many of the real policies such as quotas, reserves, or priority bonuses to this setting and show the utility functions that would characterize them. And one particular thing that's important is that additive separability induces a unique processing order for the reserve rules, where there are two kinds of seats, one kind of seats that is open to everyone, and the second kinds of the seats are reserved for particular groups on the society. And if we want the choice rules to create these two domains in an additively separable way, then the open seats must be processed at the end of the mechanism, and the reserve seats should be processed before those. I probably won't have time to go into detail for the last one, so I talked a little bit more about that right now, but I'll hope to do the first two parts in detail. There's a large literature on affirmative action and large and growing literature on affirmative action recently. I'll happy to talk more about these papers, but for the time constraints, let me do it offline unless you have particular questions. So let me try to go over the model very quickly. In this model, individuals will belong to different groups in different dimensions. So it's easy to go through an example. For example, the first dimension can be gender, where individuals in this example are either men or women. And the second dimension might be income, where individuals are either rich, middle class, and poor. They will have scores, which is a subset of real numbers. And theta of I for individual I will tell us the identity of I, which is the particular group they belong in every single dimension. And their type is given by their score and their identity. There's an institution that chooses Q individuals from a set of applicants. And we say a choice rule is a correspondence that maps the set of applicants to set of chosen applicants. Now, if the set I prime is chosen from I, first it must be available within the set I, and the capacity is filled whenever there are enough applicants to fill the capacity. The sufficient statistics to define preferences is calligraphic T, which is all possible type distributions that Q or fewer individuals can have. This is all possible outcomes that the choice rule might output, and tau phi returns the types of individuals in I. The preferences of the institution is a complete pre-order that's defined on calligraphic T, and a preference rationalizes a choice rule if whenever I prime is chosen from the set I, then it must be weakly preferred to any possible set that could be constructed from applicants. As you can see, this is very flexible representation that can incorporate various forms of diversity preferences that can depend freely on the score distribution of scores or identities of individuals, how many individuals you have from each identity, etc., etc. And finally, these preferences may not satisfy a responsiveness axiom, which basically tells us if an individual is more preferred to another, that regardless of the set that we are comparing them together with, that preference should persist. However, and then this may not be satisfied because, for example, I and I prime have different identities, and this J and J prime may have different identity distributions. However, I'll focus on the following property, which I call within group responsiveness, which tells us that conditional on identity, higher scoring individuals are more preferred to lower scoring individuals, regardless of the sets that we are considering them together with. Let me definition, and let's go to the first result. We say that a set I score dominates I prime if I is obtained by increasing some of the scores of some of the individuals in I prime. And I define a score choice cycle as the following thing: a sequence of sets of individuals, where the first is like I1, I2 to IN, such that at each step, either the previous set, IJ, is chosen when the next set, IJ plus 1, was available, or IJ dominates IJ plus 1 in terms of scores. So we create this cycle, and each step, either there is a domination with respect to choices or domination with respect to scores. And the first main result is there exists a within group responsive preference relation that rationalizes the choice rule if and only if the choice rule does not admit a score choice cycle. So this theorem gives us characterizes the class of choice rules that could be rationalized by this general class of diversity preferences. And in applications will act as like a sanity check to understand whether a choice rule makes sense or not before we move along and consider certain more stronger properties. The first application is to show that the choice rule mandated by the Supreme Court of India admits a score choice cycle. So it does not only suffer from the deficiencies that I mentioned earlier, but it's not even, it cannot even be rationalized by any kind of preferences. I'll be happy to show the full construction of this, this score choice cycle, but for the time constraints, I will not be allowed to do that right now. But one thing that I would want to say is that the college admissions mechanism in Brazil suffers from similar deficiencies, but it can be rationalized by a much simpler class of preferences. And the proof of it is basically takes the setting I have and maps it to the consumer theory. But there is one crucial difference here compared to the consumer theory, is that in that setting, we would like to observe choice data to consider rationality of a decision maker. Whereas here, we are considering the rationality of a decision maker that already chose a choice function. So we can use these results, and these results can be applied without recovering any data or even before the choice rule is being used.
You have 10 minutes, so calculating with the.
Okay. So unless you have any questions about the previous setting, let me continue talking about the intersectionality and substitutes. So once we have the rationality, then we can think about what kind of preferences, what kind of structure in preferences interact with these choice rules. And in particular, when there are multidimensional and overlapping identities, diversity can be evaluated in different ways. So I give pictures of diversity statistics of two large companies. One is Apple, that reports diversity in gender and race in a separate manner. And the right-hand side is the diversity statistics of Google, where the gender breakdown is reported conditional on each racial category, and which was also titled intersection line. Another similar conditions exist in affirmative action policies in legislatures, where even in countries with both gender and ethnic quotas in legislatures, the political scientists and sociologists emphasize that these policies are typically evolved separately and work differently compared to each other. And as a result, certain groups, certain cross-sectional groups might be disadvantages and may not benefit from these separately evolving sets of policies. So for this, I'll close the score heterogeneity for simplicity, but the paper includes score heterogeneity too. And I define a choice function to choice rule to satisfy substitutes if whenever a set is chosen from a larger set and is chosen available in a smaller set, they should be chosen from the smaller set too. So if we reduce some of the competition, the initial set should still be preferred compared to any other alternatives. The various substitutes conditions are widely used and studied in the literature, and these are crucial for the existence of equilibria and stable allocations. Sometimes we see these as desirable conditions that we try to achieve with choice rules, and sometimes we just want to understand whether certain rules satisfy these conditions or not. So let me quickly go over an example where there are, again, two dimensions. First is gender, we either have man or woman, and second is race. And then here we have underrepresented and overrepresented racial groups. And capacity of the institution is 4. And the institution only cares about the marginal distribution of identities. And for simplicity, suppose that the most preferred outcome is having 2 men, 2 women, 2 overrepresented, and 2 underrepresented individuals. And then they don't have any preferences about the cross-sectional, about whether they choose any individuals from each cross-sectional groups or not. As you can see, there are many, like a few compositions of individuals that would satisfy the preferred distribution. And one particular example is the hire a single individual from every single cross-sectional group. However, if you look at slightly alternative problem where the overrepresented man disappears, then there is no way to choose the underrepresented woman while satisfying the most preferred distribution. As a result, looking at the diversity through marginal distributions and not explicitly through the cross-sectional traits will create complementarities between certain individuals, especially the individuals who have different traits across dimensions. And as a result, this rule would not satisfy the substitutes condition because of complementarities. So the formal result says that whenever a preference relation does not consider intersectionality, which means they treat any kind of two distributions that agree on marginals as equivalent, and it values diversity in a minimal way such that the most preferred marginal distribution has at least one individual from each group, which means that the most preferred distribution does not totally exclude any group from the allocation. If these two conditions are satisfied, we have the following result. Whenever there are more than two groups, and the preference relation values diversity, then if it does not consider intersectionality, the induced choice rule does not satisfy the substitute condition. So it creates complementarities between individuals. Formalizing the example, the main mechanism in the example is not specific to that setting, but is almost generically true as long as there is a minimal valuation of diversity in the preference relation. So let me talk about very quickly about the final part now that I have a little bit of time. And as I said, I'll consider preference relations or utility functions that treat these two domains in an additively separable way. Because in certain cases, you can care about where the scores are coming from. But if scores denote the match quality and diversity considerations is to make sure that certain like fairness or fairness axioms, then there is no reason that they should be interconnected. And we'll try to understand when the choice rules can be rationalized like preferences that look in the following way, where you obtain the benefit of allocating the resource to an individual with score S, and the score utility in the score domain is summed across all the utilities obtained through score. And theta is the number of identity theta individuals in I. And H theta of N is the benefit of allocating the resource to N individuals of identity theta. And the whole preference is given by the total utility that's coming from the score domain and the total utility that's coming from the diversity domain. Not tell you any formal results, but and then the characterization. But let's look at a very quick example to understand what are the implications of requiring additive separability. Suppose that we have one dimension, two groups, and we'll choose three individuals. And one position is reserved for each of the groups. And those positions are processed after the open positions. So we'll first choose the highest scoring individual regardless of their group, then choose the highest scoring remaining A individual, then highest scoring remaining B individual. And then in this example, we have the subscripts give the scores and the letters denote the groups. And if we have the set I, then we choose A3 in the open category, and then we choose the remaining two individuals who have highest score conditional on their group. Whereas if you look at I prime, where now the B individual has the highest score, then the B individual obtains the open position, whereas A2 and this time B1 gets the slots that are reserved from each of the groups. And this suggests that this kind of processing order is not compatible with additive separability because A1 and B1, when we are considering two of them, has exactly the same diversity point. They have one people from their own group who is already chosen, and in both cases, they have exactly the same score. So they are contributing to the score domain exactly in the same way in both cases. But in one case, one is strictly preferred, and in the other case, the other is strictly preferred. And the reason for this is that this open position is actually processed before the reserve positions and affects how these reserve positions are being processed. And the result that I will not show you tells us that in any general setting, if we have these open and reserve positions, then we should process all the reserve positions first and allocate. And then once we finalize those positions, then the open positions should be processed once we have fixed all the individuals who are related to the reserve positions. Talk was 20 minutes, so I don't need to conclude. But if you have any questions, then I can allocate the remaining time to the questions.